Okay, I'll just dive in then. Okay, so plugin-oriented programming is a very new concept, and a concept that, again, I'm assuming is new to the folks inside of this call. It's we've been talking about it only for a few months, and we've got and SaltStack has produced a number of open source projects using plugin-oriented programming, and we're really just loving it so far. So, otherwise, I wouldn't be talking about it. I'd be backpedaling. So, plugin-oriented programming, I created it because, well, I created it because I began to see a lot of problems and burdens with maintaining open source code, especially open source code as it becomes larger, and taking a good hard look at scaling open source development and distributing open source development. Recently, Linus Torvalds had this fantastic quote where he said, "I don't develop anymore. My job is really just to tell people no." As he explained to a reporter recently, that what he does, right, his life isn't to produce software. His life is to review other people's code and deal with a very large community. And we therefore have one of the world's best software engineers who have been reduced to uh, just basically herding cats, which I have to admit I don't think is a fantastic reward for someone being as prolific and capable as Linus. And so, can we progress? And so, when I looked at what I had created with Pop, I realized that plugin oriented programming made it so that it became very, very easy to create a software platform that someone else can extend and modify, but they can do it externally. They don't have to give me code to review. They can modify it themselves very, very easily through this universal plugin layer that's far more powerful and inclusive than plugin layers that are, just plugin layers. And so I realized that I'd be able to create software platforms where I didn't need to review everybody else's code all of the time. And then my blessing on that code isn't what makes that code good or bad. What the contributor is able to do is independently write software that augments and extends a platform another developer has produced. And their extensions and augmentations to that platform are able to gain merit on their own and in their own right, but also seamlessly merge into other pieces of software and subsequently be seamlessly mergeable into future pieces of software. And so as we move forward, one of the things that I'm excited about is we've already, even though Pop was announced last November, and even though Pop is not very old, on the next slide I've got a great quote from Daniel Robbins. Daniel Robbins, who's become a good friend just over the last few months, has started to incorporate the use of Pop in many of the core tools that are used by the Fun2 project and subsequently also by the Gen2 project. And I love what he says when he said, "Pop is becoming a virus because it's taking over my code and killing off weak patterns. I have a lot of code that sort of reached its potential with my modules and classes and was just sitting there waiting for something like this." So Pop, again, introduces a new paradigm, a new approach, and really a whole new way of writing software, which again, even in the last few months since we announced it in November, we've got a significant number of projects that SaltStack has created, but also we're already starting to see it emerge in a few influential places. Okay, can we advance the slide, please? Thank you. So, who am I? Why should you bother listening to me? I think that that's a valid question. My name is Thomas Hatch. I am the creator of Salt and the founder of Salt Stack. I also used to work for the U.S. intelligence community. I've spent my career building and automating some of the world's largest infrastructures. I have helped build and consult on infrastructures that are backing some of the world's largest clouds, some of the world's largest financial institutions and online retailers. And I'm very accustomed to building very large pieces of software. Also, from the perspective of large open source communities, the SALT community is still one of the largest open source communities in the world. And much of what I put into POP is learning from managing and working with an extremely large open source community. And so hopefully, as I stand in front of you and say I invented a programming paradigm, I've got hopefully just enough credibility that it's worth listening to a madman who made a programming paradigm. Can we advance the slide, please? Okay, so if we take a brief look at the history of computing, and I'm going to make this as brief as possible. Early software was really developed to do math, and if we go back into the 60s, build the building of the world's first, what we would now term operating systems. Unix came about at the end of the 60s and matured in the early 70s. And with it, we got the Unix philosophy. Now, at that time, software was interacted with through a shell almost entirely. And from a programming paradigm perspective, what we were looking at was procedural and functional programming largely, if almost completely. And the Unix philosophy became a really fantastic way to write software, in that we were able to make pieces of software that you could chain together because of the simplicity of the concept of a shell as that base interface that we're working with. But as we enter into the late 80s and the 90s, we have the rise of the GUI. And with the rise of the GUI, we have the rise of object-oriented programming. Now, of course, object-oriented programming was developed before the GUI, but the GUI is really when we started to see object-oriented programming become very, very widely used. And the push for the desktop application, the era of the desktop application as it emerged in the early 90s and evolved through the mid-2000s. Really, that became that dominant paradigm. And this is where we see the evolution of Java and Qt and GUI toolkits, but also Windows, and the dominance of Windows as a provider of that platform for graphical applications. It's also the time where we used to say every year, this will be the year of the Linux desktop, something which I still bemoan that KDE has not achieved the dominance that I feel it deserves. So with this, though, object-oriented programming became very dominant. And that was the focus of, again, a huge amount of software engineering. But the modern world, as it has evolved in the last 10 to 15 years, has seen a shift to SaaS and a dramatic shift into leaning in to open source software. If it wasn't for open source software, the platforms of today we certainly would not be able to create them. And so I feel as though there are new challenges that we need to approach and new ways of thinking about software. The very way in which we develop software has changed so dramatically in the last 10 years that we no longer think of software as a single office full of engineers who are working on monoliths, but we think of software following many of the principles of the Unix philosophy, lots of small pieces of software which hopefully are beneficial to one another. And this, again, is my motivation behind POP. Can we advance the slide, please? And so object-oriented programming has limitations when it comes to scaling software. It becomes very difficult when you have large object-oriented programming applications to hand those applications off to new maintainers and to share the load of maintainership. Therefore, it's very good at and focuses on building proprietary style monoliths. When I say proprietary style, I also want to mention the fact that proprietary style monoliths are also have emerged in open source, especially over the last decade, as we've seen significant investments from venture capital as well as corporate investments flow into open source software. We've seen more open source software platforms become large monoliths and leave the concepts of that Unix philosophy behind. Another thing that I mentioned briefly before is that while I love contributions, don't get me wrong, but when you're having to process between 80 to 200 pull requests a day, it becomes quite onerous and difficult to maintain quality of code. It also becomes onerous and difficult to stay on top of the demands and needs of a large community. Even as you distribute that work among many contributors, and over the years I've certainly seen this, uh, the probability of bad code getting into a project goes up and up. And it becomes exponentially more difficult to maintain that PRQ. Testing of monolithic software has also become a serious issue. We could talk for hours on end about large software projects that take hours, sometimes literally days, to test any change, which slows down and impedes all of our attempts to release and deliver software quickly. The second to last thing I wanted to mention is that back in 1974, there was this fantastic book that came out called The Mythical Man Month. The Mythical Man Month suggested that you can't hire more engineers and get the same linear output of more engineers. And I feel that plugin-oriented programming can address this problem. Bifurcating and making applications smaller and mergeable means that it's easier to take small groups of engineers to work on targeted applications and targeted components. And those small groups can then bring those components together in a more seamless way. That approach should allow us to overcome the Mythical Man Month, something which we still struggle with today, and arguably in a much bigger way than when that book was published in 1974. And the last thing I want to mention here is that there's more to freedom. I should change. I shouldn't say freedom is not a license. I should say there's more to freedom than a license. Just because we make something open source, it doesn't necessarily mean that we deliver freedom to the developer. In the last 30 years, we've seen some open source developers have fantastic careers, while I have to admit on the other spectrum, we've seen many open source developers succumb to what can be described as nothing less than mental illness. The amount of stress that we put on and the onus that we place on open source developers in comparison to the reward often given is the opposite of freedom. It is bondage by the means of their own creations. And I fear that that is something which can have a seriously negative impact on our ability to sustain open source in the long run. If we have a way to write software that lowers the burden of maintainership and spreads the ability to extend and enhance software in a more independent fashion, I feel that we can overcome many of the hurdles that we have ahead of us when it comes to maintaining extremely large software platforms. Next slide, please. So again, the hope is that plugin-oriented programming brings an answer to this, that we are able to address the Unix philosophy in a new way, that we are able to approach software in a way in which we can always have software as small, compartmentalized, individual, testable components that are easily merged and combined with one another. And that at the end of the day, what we get is not only better software, but also more freedom for the developers, more flexibility from a business perspective, as well as more flexibility and the ability to maintain software platforms in the long run. Next slide, please. So I want to revive the Unix philosophy. The first two things are basically unchanged. We do one thing, program does one thing and does it well. Next, programs work together. Programs need to be written in such a way that they can communicate with one another in a completely standard way. And then finally, the original Unix philosophy said that we write programs that communicate over text because it's the universal interface. My argument with plugin-oriented programming is that now we can write programs that expose a consistent mergeable interface so that those applications can be completely merged one with another. Next slide, please. So where did the idea of plugin-oriented programming come from? So I wrote Salt, and inside of Salt, there's a concept called the Salt Loader. It's Salt's plugin system. And so Salt's plugin system allows you to have plugins in Salt. And only within the first few years of Salt development, we had many people who are coming back and saying that the flexibility and the power of Salt's plugin system was really the biggest benefit that it was delivering. And I thought that it was really interesting that people were gravitating towards what I hadn't given a whole lot of stock at first. And so I thought to myself, what would it look like if I built a standalone plugin system? And so I basically forked the Salt loader and created a plugin system and thought, hey, this is really nice. This is a good idea. Now that I'm not trying to support the concepts inside of Salt, I can actually break some things and improve some things. So I made a new plugin system and didn't like it, and then re-implemented the idea in a number of different programming languages. And eventually I wrote it in Julia. And when I wrote it in Julia, my eyes were opened in a lot of different ways. And so then I came back and re-implemented it from scratch in Python again. At which point was when I realized that I had actually created a programming paradigm through my journey of just trying to make a really cool plugin system. I realized that what I had produced was a paradigm. I didn't set out to build a programming paradigm. The programming paradigm is what I ended up with as I created a platform where 100% of the software can be pluggable. And then I realized that not only was it a paradigm, but it was also a paradigm which, frankly, and arguably, I think is much easier to learn than object-oriented programming, much easier to follow, and creates much more maintainable code and enforces that all code maintains pluggability. Next slide, please. And so if we start with a plugin-oriented programming project, you first install POP. So POP is an application that you can install via PyPy. All your standard Python goodness is in place. It requires Python 3.6 or higher currently. And once you install POP, you get a little application called POP Seed. POP Seed sets up the basic structure of a POP project. Now, in doing so, 90% of that structure is setting up a setup.py and just creating a few basic folders. It still looks and feels like you're writing, you're still writing software in Python. And obviously the POP concepts and ecosystem are built to leverage the ecosystem and the capabilities that already exist in Python. One can think of plugin-oriented programming in a similar way, in that it's built on top of Python in a similar way that C++ is built on top of C. If you pick what I would argue is the best language of the day, I'd pick Python. We can have a debate about that later, since it's a very difficult challenge. So you run the POP Seed application, and it gives you a setup.py that's nice and crisp and generic that will automatically detect everything that you put inside of your POP project, so it shouldn't need to be modified very much. But it also sets up some hooks for running black on a project. And it enables one of the other things that's really important here, which is a new build system that we've got along with POP as well. Next slide, please. Okay, so POP seed lets you start. But the next concept in here is I just touted that I've got a platform that you can have two completely separate apps that are 100% applications, and you can seamlessly merge those applications together. How does that work? And so that works through two concepts that are really important. One is configuration loading, and another is app merging. Advanced slide, please. So if we want to be able to merge two applications together, we have to be able to take care of and facilitate the mechanism for the startup of those applications. So that if I write an application over here and it runs and has merit and objectivity on its own, it needs to be able to be executed. It needs CLI options and all those things. And I've got another application with its own options, and I can merge them together onto a third application, or merge or have one application that needs all the functionality of another application. All of that configuration input needs to also be portable. And so POP comes with a system called POP config that allows to merge application configuration dynamically without the developer having to, frankly, really do anything. All they've got to do is say, yeah, I'm going to merge with this other application. And the CLI, for the most part, is dynamically generated. The config loading is completely capable, and all of your config information gets loaded into the new application to support all merged applications. Now, to build a CLI management system, you've got a bunch of problems that are solved in POP config. You've got to take options from the CLI, from environment variables, from config files, and defaults. They have to be loaded in the right order. And then you want to be able to define documentation and all these things in a single place. POP config does all that. That's a whole nother discussion. Next slide, please. The next concept is that if we're building applications, I really felt a strong need to, frankly, try and put a nail in the coffin of how hard it is to deploy Python applications to end users. We're all very familiar with the fact that in Python, it can be quite difficult to write an application and then deploy it to an end user's system, because you're dependent on what version of Python they have installed. What dependencies they have are important. You have to share a very large set of dependencies with multiple other applications. And so it can make it very cumbersome to deploy applications in Python as they grow. And one of the big reasons I'm going to argue that Go has done so well is because they're able to deploy these single binary applications. Now, this has been attempted numerous times in Python to create single binary applications, but there's always been a challenge with making a way that it's really generic that is really generic to produce those binaries. Another thing that I would argue about Python binary build systems is that they generally require you to run them post-install. And they always end up with some silly caveat that makes things rather difficult. And so for this reason, we also have a tool called POP build. Advanced slide, please. POP build is created in such a way that it leverages how Python packaging natively works anyway, so that you can extend the Python packaging system and pip to be able to very, very easily run POP build and spit out a binary of that Python project, and that you don't need to modify that project so that it can run under using pop build. So we've solved many of the problems that have persisted inside of PyInstaller with pop build. It uses PyInstaller because those guys do a fantastic job. But again, it makes it incredibly easy. You can pick almost any Python project, write an entry point for the project, which is usually anywhere from 2 to 4 lines of Python, run pop build, and bam, you get a working single binary that includes Python and is portable to other distributions or other platforms. Next slide, please. Oh, I already covered this. So next slide, please. Okay. Now I'm almost out of time. And so the last thing that I want to mention is application merging. So this is an introduction talk. This isn't a big course on how to use plugin-oriented programming, but app merging comes in two forms. One is called vertical application merging, another is horizontal application merging. So horizontal application merging means that we take two applications and merge them together horizontally, so to speak. The other way is that you've got a plugin subsystem, and that plugin subsystem or that collection of plugins can be extended by an external application. And again, if I had more time, I would give you guys a bunch of examples and demonstrations along these lines. It seems that I've tried to pack a little too much information into the time allotted. I apologize. I'm usually pretty good at not doing that. If you are interested in plugin-oriented programming, there is a book that is available on Read the Docs. It's a brief book. It's about 50 pages that gives an overview of the ideas behind plugin-oriented programming, where the concept came from, as well as how to use the core components of plugin-oriented programming so that you can have app merging, config merging, plugin building, using pop build, and coming to this ecosystem. I tried to make it as brief a read as I could while conveying and getting across, hey, this is how to engage with plugin-oriented programming. I've already had quite a few folks who were working with us early on. This book has only been out for about 3 weeks. Come back and be very, very excited about the book. It answers a lot of the questions that they've had. Again, trying to bootstrap a programming paradigm is kind of a mess. But that's located at popbook.readthedocs.io. As I'm out of time, I'll ask, does anybody have any questions, comments, arguments, or rebuttals? Because I've thrown a doozy out there.
So we can all stay in this session here for the time being, because Thomas, you were the last speaker in the program we had. So if anyone has a question, go ahead and ask Thomas. And if you want to continue, we could also continue with your slides if you want. It's still recording.
No, I mean, that's okay. I don't want to overdo anybody. I've used my time. I will accept that.
I'm only quiet because I'm looking up the book. It's very interesting. Very interesting proposal. I like it.
Yeah, I appreciate that. And really, I mean, my motivation here was that the SALT system works really well with lots of plugin systems, which is why we've got over 35 plugin subsystems inside of SALT. And I kept looking at it going, I literally have 15 products inside of SALT. And from a development perspective, a community perspective, and a business perspective, I keep looking at it going, I wish that I'd broken all of these out. I wish that I'd had a platform and a way of doing that. And subsequently, with POP, we've started to inside of SaltStack, we've started to break a few of those pieces out. So grains, for instance, we've broken grains out. We haven't taken it out of salt yet. We're looking at doing that, but we've created a mechanism. We've created a system with POP that makes it really easy to extend the grains system as it exists inside of salt. We hope to get that in, not with the upcoming sodium release of salt, but in the magnesium release. Similarly, there's now a standalone version of the salt config management runtime, which has actually already become more featureful than salt's config management runtime, even though I've only been working on it for about 8 months, called Item, which is kind of short for idempotent. So yeah, I'm trying to prove the model instead of just peddling a blind model.
Yeah, sure. No, it looks very interesting. I'll be looking at. What's the URL of the book?
The URL of the book, is there a chat in here?
No, unfortunately. So there's a Telegram channel that which might be better.
So it is pop-book.readthedocs.io.
Read. Okay.
Yeah, and the sources for it are on GitLab/saltstack/pop/popbook. But yeah, goodness, I would love feedback. And again, I mean, sorry, go ahead.
No, that's just check it out now.
Yeah, I'd love feedback because I'm really at this point just saying, hey, I think this is useful, and if other people think it's useful, that's great. It's already enough that I'm betting on it. But if other people want to bet on it, great.
Yeah, I'll just paste that into the Telegram.
Could you put it in the Etherpad too, Patrick?
Yeah.
Yeah, and this is actually one of the challenges that I run into. I've only given this talk a handful of times, but I get to the end, and there are very few questions, primarily because it's, hey guys, here's totally freaking out of left field. Yeah, but it does follow a lot of concepts of microservices, but with the idea that deployment of the artifact or the result is significantly simplified, because you can still develop in a microservice fashion, but you get the benefits of a monolithic deployment. And you could still use POP to deploy in a microservice fashion as well, of course.
So you compile the Python into binary code.
So the Python is the Python works like Python. It can be pip installed, so it's direct continuation of just good old Python. You publish to PyPy, all that good stuff. But the pop build option is there to produce either a single binary or a single directory full of all of the binary components,
Right.
again, including Python. It uses PyInstaller under the hood, but what we do is kind of fiddle around with PyInstaller a little bit so that we're able to maintain code paths inside of the binary. That allows us to still be able to do things like dynamically look up plugin locations.
Okay.
The other thing I should mention is that I originally wrote pop build to build pop stuff, but I've been able to arbitrarily compile virtually any Python project.
Yeah, just looking up, we've used the Python compiler. Just trying to remember what it's called.
PyInstaller, PyOxidise, BBFreeze, Esky.
Noitka.
Oh, Nuitka. I love Nuitka.
It's very good, isn't it?
Yeah, I'm not using Nuitka. There's
that takes everything back to C++ and then compiles it as C, doesn't it? Yeah.
Yeah, Nuitka does a transpile, and as such, so again, I love Nuitka. But when you use Nuitka, you actually lose a number of features from Python. And so your code really has to, really, in the end, it has to be geared towards Nuitka. I wanted something that was a little more universal.
Yeah.
I also had a hard time figuring out how to trace plugin loading when all the components had been statically compiled that way. It was really hard to detect plugin organization.
Yeah.
With that said, again, kind of to be blunt, I'd rather use Nuitka's approach.
Mm.
But at the same time, I don't think I've got the 2 years I'd need to write the code to make it work.
Who does?
Right. Or I should say, and I'm not saying that to make Nuitka work. Nuitka works. I love it.
Mm.
But to make the plugin dynamic loading, that whole thing work reliably in Nuitka, my conclusion was this is going to take anywhere from 6 months to 2 years of me doing nothing else. And
Yeah.
yeah.
You know, I had one particular project we had to come up with a binary source, so a binary build for, and I found it and I thought this is pretty good and it's pretty fast as well. And and I did work out ways to include so I have a certain Python files which weren't part of the compiled bit, and you just include them, and they. But yeah, no, it's good. It's good. I'll be definitely taking a look at your stuff.
I appreciate it.
Not that I don't know about Salt and haven't used Salt, because I have, and that's very good as well.
Thank you. Yeah, but I mean, even just taking a look, that's why I'm talking about it.
Yeah.
See if I can get feedback. See if people can help me find more edge cases, so it can grow up into a more, hey, this is a totally legit, mature paradigm. That'd be cool.
Yeah. All right.